In this video we're going to look at how to find the equation for the inverse of a function. And before we get started, let's just review the steps for finding the inverse of a function, or look at them if you've never seen them before. And then we're going to go through an example step by step here. So to find the inverse of a function, the first thing you want to do is substitute y in for f of x. After you do that, you're going to switch the x and the y. After you switch them, then you're going to solve for y. And once you have your equation solved for y, you're going to substitute f inverse of x back in for y. So those might be just a bunch of words to you now. Let's look at an example. Let's start with f of x equals 2x minus 4. Now hopefully, just looking at this, you know what kind of a graph this is going to make. This is a linear equation. It's in the form y equals mx plus b, or f of x equals mx plus b. So this is a line. That means that it is a function. Obviously it's a function, it's in f of x form, but it's also a one-to-one function. It would pass both the horizontal and the vertical line test, so it does have an inverse. Not all functions have inverses. It has to pass both the horizontal and the vertical line test to have an inverse. And we're going to look at a graph of this after we get the equation. So what we want to find is the inverse of 2x minus 4. So step number 1, we're going to substitute y for f of x. That's easy. Alright, that's an easy step. Okay, step number 2, switch x and y. So I'm going to flip the x and the y here. Instead of y, I'm going to write x, and instead of x, I'm going to write y. Notice everything else stayed exactly where it was. The 2 stayed on the right hand side, and the minus 4 stayed on the right hand side. I just switched the x and the y. And you always do this. Anytime you're finding the inverse function, you switch the x and the y. Now the next thing we're going to do is solve for y. So now y is over here. It's not by itself anymore. We need to get y by itself. So we're going to use our basic properties of equality to do that. We're going to add 4 to both sides, which gives us x plus 4 equals 2y. And then we're going to divide everything by 2. And I'm going to go ahead and write this as a linear kind of equation. So I'm going to think of this as 1x. So I can rewrite that as 1/2 x plus 2 equals y. That's step 3. That's the biggest step. That's the step that's going to take the most time, is solving for y. And the last thing, you're just going to substitute f inverse of x in for y. That would give me 1/2 x plus 2 equals f inverse. Alright, or I could rewrite it f inverse of x equals 1/2 x plus 2. Our original equation, f of x equals 2x minus 4, has an inverse function of f inverse of x would be 1/2 x plus 2. Let's go ahead and look at a graph of this. I think that's important. Let's see if I can pull a graph up here. Might have to go get one. Just bear with me for a minute. It'll be worth it when we have this nice graph paper. I'm going to have to cover up part of my space here. Maybe I can make it smaller. No, it didn't work. Okay, we'll just leave it like that. That's fine. So let's graph our original equation in blue. F of x equals 2x minus 4. Remember, that's a linear equation, so the y-intercept's at -4. Should be right there. And then the slope is 2, so I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, etc. And then I would get a line. Just like that. Now let's graph the other equation in purple. Let's graph the inverse in purple. I'm having a little trouble here. Let's choose the right tools, and then we'll graph it in purple. There we go. Y-intercept is positive 2. The slope is 1/2. Up 1 over 2. Up 1 over 2. Up 1 over 2. And we could also go down 1, left 2, and there's our inverse. Now you may have seen this before. When you graph a function and its inverse, there's going to be a reflection. Let me do that in red. This line here in red is the line y equals x. It's at a 45-degree angle through the first quadrant and the fourth quadrant. And if you took your function line, this blue one, f of x, and you reflected it over this red line, it would land on your inverse function. That's how those relate to each other. And another way to kind of check that your function is right, any point on this line, let's look at this point right here. You just pick any point on your function. This point right here is over 3 up 2. If I flip those, flip the order and put the 2 first and the 3 second, the 2 is the x and the 3 is the y, that should give me a point on my inverse, which it does right there, over 2 up 3. And that's why you get this reflection over the line y equals x. And that might be good to know. This line right here is y equals x. It has a y-intercept of 0 and a slope of 1, up 1 over 1. And that characteristic is always going to be true when you graph a function and its inverse, is you can just reflect it over this line y equals x. I hope that helped, and if you have any questions, just let me know.